Welcome to my video on tasks and functions in SystemVerilog. If you are new to SystemVerilog or just starting out, you may have heard of tasks and functions, but may not know exactly what they are or how to use them effectively in your code. Well, in this video, I will be providing an introduction to tasks and functions in SystemVerilog, discussing their differences and similarities, and showing you how to write and use them in your own code. By the end of this video, you will have a better understanding of tasks and functions and be equipped with the knowledge to write more efficient and effective code in SystemVerilog. So, let's get started. We will be discussing tasks, functions, and different argument passing methods. Here is a quick overview of what we will be covering. First, we will dive into tasks and functions, which are used to group related actions and to define reusable code, respectively. We will explore the differences between the two and provide examples of their syntax and usage. Next, we will look at different ways of passing arguments in SystemVerilog, such as pass by value, pass by reference, pass by name, and pass by position. So without further ado, let's dive in. In SystemVerilog, a task can contain a declaration of parameters, input arguments, output arguments, in-out arguments, registers, events, and 0 or more behavioral statements. There are two types of tasks in SystemVerilog. What are tasks? A task is a block of code that performs a specific action or a sequence of actions. Tasks can be used to break up complex code into smaller, more manageable pieces. Tasks can have input and output arguments, which can be used to pass data between the task and the calling module. The syntax of a task in SystemVerilog is similar to that of a module. It starts with the keyword task, followed by the task name and any input or output arguments. The body of the task is enclosed in curly braces. Syntax of a task. Task underscore name, input arg1, output arg2. Task body. End task. In this example, task underscore name is the name of the task, arg1 is an input argument and arg2 is an output argument. The body of the task goes between the task and end task keywords and can contain any valid SystemVerilog code. Now we will be discuss the different capabilities of SystemVerilog tasks, including their storage space allocation and the various ways in which arguments can be passed. Static tasks. Let's start with static tasks. Static tasks share the same storage space for all task calls. This means that any variables declared within a static task will retain their values between calls. Furthermore, SystemVerilog allows declaring a static variable in an automatic task, which can make the code more efficient and help in reducing memory usage. Automatic tasks. On the other hand, automatic tasks allocate unique, stacked storage for each task call. This means that any variables declared within an automatic task will have a new instance created for each call, ensuring that each call operates independently of the others. Task capabilities. Now let's move on to the capabilities of SystemVerilog tasks. One major advantage of tasks is that they allow for multiple statements within a task without requiring a begin, end, or fork, join block. This makes the code cleaner and easier to read. Another advantage is that tasks allow for returning from the task before reaching the end of the task. This can be useful in situations where you want to exit the task early, without executing all of the code within it. Tasks also allow for passing values by reference, value, names, and position. This flexibility makes it easy to customize the way that arguments are passed into a task depending on the requirements of your specific code. Furthermore, tasks support default argument values. This means that you can define a default value for an argument, which will be used if no value is explicitly provided. Finally, it's important to note that the default direction of an argument is input if no direction has been specified, and the default argument type is logic if no type has been specified. Now, let's take a look at some examples of SystemVerilog tasks. First, let's see an example of a SystemVerilog task with arguments in parentheses. In this example, we have defined a task named sum that takes two input arguments A and B and one output argument C. Within the task, we have added the two input arguments and assigned them to the output argument. Then, we have called the task in the initial block with input values of 10 and 5, and the output is assigned to variable x. Finally, we have printed the value of x using the $display statement. The output of this simulation will be value of x is equal to 15. Next, let's see an example of a SystemVerilog task with arguments declared separately and direction mentioned. In this example, we have defined the same task, sum, but declared the arguments separately and mentioned their direction. We have defined A and B as input arguments and C as an output argument. Within the task, we have added the two input arguments and assigned them to the output argument. Then, we have called the task in the initial block with input values of 10 and 5, and the output is assigned to variable x. Finally, we have printed the value of x using the $display statement. The output of this simulation will also be value of x is equal to 15. In SystemVerilog, a function can contain declarations of range, returned type, parameters, input arguments, registers, and events. A function without a range or return type declaration returns a 1-bit value. What are functions? Functions are blocks of reusable code that return a value. Like tasks, functions can have input arguments, but they do not have output arguments. Functions can be used in expressions, allowing you to perform complex calculations and return values to the calling module. Syntax of a function. The syntax of a function in SystemVerilog is similar to that of a task. It starts with the keyword function, followed by the function name and any input arguments. The return type of the function is specified after the input arguments in parentheses. The body of the function is enclosed in curly braces and must include a return statement that specifies the value to be returned. Function return underscore type function underscore name, input arg1, input arg2. Declarations. Function body. Return underscore value. End function. In this example, return underscore type is the type of the value that the function returns, function underscore name is the name of the function, and arg1 and arg2 are input arguments to the function. The body of the function goes between the function and end function keywords and can contain any valid SystemVerilog code. Finally, the return statement specifies the value to be returned by the function. Functions can be static or automatic. Static functions share the same storage space for all function calls, while automatic functions allocate unique, stacked storage for each function call. SystemVerilog allows for more capabilities for declaring function ports, multiple statements within a function without requiring a begin, end or fork, join block, returning from the function before reaching the end of the function, passing values by reference, value, names, and position, default argument values, function output and in-out ports, and more. Let's take a look at some function examples. In this first example, we create a function to add two integer numbers using parentheses to define the arguments. In the first code example, we create a function named sum that takes two integer arguments a and b. Inside the function, we add these two arguments together and assign the result to the function name sum. In the main program, we call this function with the arguments 10 and 5 and assign the return value to the variable x. Finally, we display the value of x using the $DisplaySystem function. The output of this code will be value of x is equal to 15. In this second example, we use argument declarations to define the input arguments. In the second code example, we use argument declarations to define the input arguments for the sum function. We declare the input arguments a and b inside the function rather than using parentheses to define the arguments. The rest of the code is the same as the first example. This code will also output value of x is equal to 15. In this next example, we use the return keyword to specify the function's return value. In the third code example, we use the return keyword to specify the function's return value. Instead of assigning the result of the addition to the function name sum, we use the return keyword to specify that the result of the addition should be returned as the function's output. The rest of the code is the same as the first example. This code will also output value of x is equal to 15. We can also create void functions, which have no return value, like this. In the fourth code example, we create a function named current_time that has no input arguments or return value. Inside the function, we use the $TimeSystem function to display the current simulation time. In the main program, we call this function twice, once after a delay of 10 time units and again after a delay of 20 time units. The output of the program shows the current simulation time at each call to the current_time function. The output of this code will be current simulation time is 10. Current simulation time is 30. Finally, it's important to note that function return values must be assigned to a variable or used in an expression. Calling a function without assigning its return value to a variable can result in a warning message, but we can use SystemVerilog's void data type to discard a function's return value without any warning message, like this. In the fifth code example, we demonstrate that function return values must be assigned to a variable or used in an expression. We create a function named sum that adds two integer arguments a and b and returns the result. In the main program, we call this function using the void syntax, which discards the function's return value without generating a warning message. The $DisplaySystem function is used to show a message indicating that the function is being called with void. This code will output calling function with void. Now, we are going to talk about the 4 different ways to pass arguments to functions and tasks. First, we have argument pass by value. When a variable is passed by value, a copy of its value is made and passed to the function. Any changes made to the variable inside the function do not affect the original variable outside the function. Next, we have argument pass by reference. When a variable is passed by reference, the function receives a reference to the original variable. Any changes made to the variable inside the function also affect the original variable outside the function. Third, we have argument pass by name. When a variable is passed by name, the variable name is passed to the function, and the function can access the variable using the name. However, this method is not commonly used in SystemVerilog. Finally, we have argument pass by position, which is the default method of passing arguments in SystemVerilog. Arguments are passed to the function in the order they are listed in the function call. The first argument in the function call corresponds to the first argument in the function definition. The second argument in the function call corresponds to the second argument in the function definition, and so on. Let's start with argument pass by value. In argument pass by value, each argument is copied into the subroutine area. Any changes made to the argument within the subroutine will not be visible outside. Let's take a look at an example. We have two variables, x and y, that are passed as arguments in the function called sum. Within the function, we add x and y and store the result in x. However, when we print the values of x, y, and the result, z, outside the function, we see that only the value of z has changed. This is because the changes made to x within the function were not visible outside. The output of the code will be: value of x is equal to 20. Value of y is equal to 30. Value of z is equal to 80. Now let's move on to argument pass by reference. In pass by reference, a reference to the original argument is passed to the subroutine. As the argument within the subroutine is pointing to the original argument, any changes made to the argument within the subroutine will be visible outside. To indicate argument pass by reference, the argument declaration is preceded by the keyword ref. Let's take a look at an example. We have the same variables x and y as before, but this time we pass x by reference using the ref keyword. Within the function, we add x and y and store the result in x. When we print the values of x, y, and z outside the function, we see that the value of x has changed as well. This is because x was passed by reference, so changes made within the function were visible outside. Now, any modifications to the argument value in pass by reference can be avoided by using the const keyword before ref. This will lead to a compilation error if any attempt is made to change the argument value within the subroutine. The output will be: value of x is equal to 50. Value of y is equal to 30. Value of z is equal to 80. Now, we will take a look at the difference between pass by value and pass by reference. In this code, we are demonstrating the difference between pass by value and pass by reference in SystemVerilog. We start by declaring a variable x with the value of 10. We then define two functions, pass_by_value and pass_by_reference, to perform some operation on the input parameter y. The pass_by_value function takes the input parameter y by value, meaning that a copy of the value of x is passed to the function. On the other hand, the pass_by_reference function takes the input parameter y by reference, meaning that the function directly modifies the original value of x. In the initial block, we first call the pass_by_value function with x as the input parameter. The function doubles the value of y and displays it using the $display function. However, the value of x remains unchanged after the function call, since only a copy of its value was passed to the function. Next, we call the pass_by_reference function with x as the input parameter. The function doubles the value of y and displays it using the $display function. This time, the value of x is also changed to 20 since the function modifies the original value of x directly. Finally, we display the values of x after each function call using $display. As expected, x remains unchanged after the pass_by_value function call and is modified to 20 after the pass_by_reference function call. The output of this code shows us the values of y inside each function call and the final values of x after each function call. We can clearly see that pass_by_value does not modify the original value of x, whereas pass_by_reference does. This demonstrates the difference between pass-by-value and pass-by-reference in SystemVerilog. Now, we will be discussing the pass-by-name method. This method allows us to pass arguments in any order by specifying the name of the argument. Let's take a look at an example in SystemVerilog. Here, we have a module named argument_passing. Inside the module, we have a function named display that takes two arguments, an integer x and a string y. Notice that when we call the display function, we are not passing the arguments in the same order that they were defined in the function. Instead, we are passing the value of y first, followed by the value of x. We are able to do this because we have specified the name of the argument when we call the function. Passing arguments by name is particularly useful when you have functions that take many arguments and you want to avoid mistakes caused by passing arguments in the wrong order. By explicitly naming the arguments, you can ensure that they are being passed to the function correctly. The output will be value of x is equal to 2016, y is equal to hello world. To summarize, pass-by-name is a method of argument passing that allows us to pass arguments in any order by specifying the name of the argument. It's a useful technique for avoiding mistakes when passing arguments to functions. Now, we will be discussing the pass-by-position method. This method allows us to pass arguments based on their position in the function's argument list. Let's take a look at an example in SystemVerilog. Here, we have a module named argument_passing. Inside the module, we have a function named display that takes two arguments, an integer x and a string y. Notice that when we call the display function, we are passing the arguments in the same order that they were defined in the function. We are able to do this because the pass-by-position method relies on the position of the arguments in the function's argument list. Passing arguments by position is the most common method of argument passing. It's simple, intuitive, and easy to understand. However, it's also prone to errors if you accidentally pass arguments in the wrong order. Let's take a look at an example of this. Suppose we want to swap the values of x and y using a function called swap. We might define the function like this. In this example, we define a function called swap that takes two integer arguments, x and y. Inside the function, we swap the values of x and y using a temporary variable, and then we print the result. However, when we call the swap function in the initial block, we accidentally pass the arguments in the wrong order. As a result, the function swaps the values of a and b, but we still see the original values of a and b printed out. To avoid mistakes like this, it's a good idea to use named arguments whenever possible. That way, you can be sure that the arguments are being passed to the function correctly. To summarize, pass by position is a method of argument passing that allows us to pass arguments based on their position in the function's argument list. It's simple and intuitive, but it can be prone to errors if you accidentally pass arguments in the wrong order. To wrap up, in this video, we covered the basics of SystemVerilog, including its syntax and data types, as well as the use of tasks and functions to perform operations and simplify code. We also discussed the 4 different ways to pass arguments to functions and tasks, including argument pass by value, argument pass by reference, argument pass by name, and argument pass by position. Understanding these different methods can help you choose the best approach for your specific application. Thanks for watching, and I hope you found this video helpful. If you have any questions or comments, please leave them down below. If you enjoyed this video, please consider giving it a thumbs up and subscribing to our channel. We regularly post videos on digital design and verification, so be sure to stay tuned for more great content. Once again, thank you for watching. This is Zairaj Mirashi signing off, and we will see you in the next video.